Look, the starting gun for the global AI race has officially fired. But a massive physical wall is emerging right in front of us. We're completely moving past the era of shiny model announcements into a brutal infrastructure reality. Enterprises are crashing directly into the physical limitations of legacy systems. The AI power collapse isn't some abstract future threat. It's the immediate reality defining the blueprint for 2026.
1.6 terabits per second. Just let that scale sink in for a moment. This is the staggering level of interconnection we're talking about now. We absolutely have to stop treating enterprise AI transformation as merely a software update. It's a severe, high-stakes hardware and power dilemma. Honestly, if you can't move data at this kind of velocity, your intelligence initiatives are practically paralyzed on day one.
So, the crucial question for enterprise leadership right now is this: where does your AI actually live? It's time to confront the physical footprint of your corporate AI strategy. As hyperscalers play this endless game of one-upmanship, chasing new benchmarks and capabilities, organizations are being forced to answer whether they actually possess the power, the cooling, and the connectivity to support these unfathomable workloads.
Section 1. Internet versus enterprise AI.
We're seeing a fundamental divergence in AI architecture. Internet-scale models get all the media attention, right? These are the general-purpose chatbots scraping vast public datasets to predict the next word. But enterprise AI? That's a highly specific private domain. It requires training small to medium-sized models on incredibly sensitive operational telemetry, dense financial records, and years of internal transactional history. The mechanical requirements of scraping the public internet versus security analyzing your localized proprietary data, they're just entirely different beasts.
And this mechanical split creates a massive architectural debt that we call data gravity. Basically, it's the immense logistical and financial friction of moving petabytes of telemetry across standard networks. Think of it as the digital equivalent of trying to haul physical freight cars down a bicycle lane. The data is simply too heavy. When you're dealing with tens of thousands of devices streaming telemetry all at once, you're instantly managing data in the petabyte range. And that renders legacy network pathways completely obsolete.
Let's look at the exact operational friction of the 10-gig bottleneck, because it's severe. Attempting to push petabytes over standard internet links results in literally hundreds of hours of latency. Structurally, the financial damage just compounds. While you sit there waiting for that data transfer to complete, you're continuously paying by the drink for high-end compute resources that are just sitting entirely idle. It is an unsustainable waste of capital. Modern latency demands an entirely new, cost-effective bandwidth fabric to eliminate that compute idle time for good.
Section 2. The power squeeze and structural friction. Now, the landscape is shifting heavily toward neoclouds. These are specialized, highly flexible AI-focused cloud environments designed to optimize hardware like high-density GPUs and TPUs. From an analytical perspective, the processing side is technically getting solved. We've got vastly more efficient hardware for inference, with new alternative accelerators continuously hitting the market to maximize your compute per token. The catch? The raw commercial grid power required to actually keep them running is absolutely not keeping pace. This brings us to ghost capacity. This is the exact structural variable causing utility gridlock all over the map. We're talking about massive blocks of megawatts officially reserved for data center consumption, but never fully utilized by the operators. Utilities have been repeatedly burned by this ghost capacity. This imbalance has caused severe, systemic strain on power providers, who have to carefully manage grid stability without blowing out the local infrastructure. Because of this systemic strain, utilities are aggressively redefining their terms of service, and the resulting utility gridlock is brutal for multi-tenant operators and enterprises alike. Power providers are enforcing impossibly long queues and multi-year timelines just for new electrical deployments. More critically, they are enacting strict mandates requiring payment for a very high share of the capacity requested, whether you actually use it or not. Trying to build an on-premise, high-density AI environment on a standard corporate campus, under these strict commercial constraints, it's virtually impossible. So to bypass these massive bottlenecks, we're seeing an incredible migration of industrial technology. Co-location facilities are actually abandoning traditional grids in favor of self-generation, literally repurposing tech originally developed for the oil and gas sector. By integrating fuel cells, advanced turbines, and natural gas-based generation directly on site, facilities can permanently decouple themselves from this utility gridlock. Right now, this is the only reliable method to secure the continuous, uninterrupted megawatts necessary for dense AI computing.
Section 3. The Tactical Co-location Architecture Plan.
Okay, here is the step-by-step architectural transition an enterprise must execute to survive this. Step 1. Migrate your high-density workloads away from the fundamentally limited on-premise campus and move them into purpose-built co-location facilities equipped for severe power draws. Step 2. Interconnect directly with traditional hyperscalers and specialized neoclouds at ultra-high speeds. We're talking 400 gigabits up to 1.6 terabits per second. And Step 3. Deploy your inference hardware as close to your end users as physically possible to aggressively eliminate latency.
You have to remember that flexibility is no longer a luxury. It's an absolute infrastructure design imperative. The landscape is evolving way too fast to risk vendor lock-in. Centralizing your operations in a highly connected environment guarantees you the critical ability to shift workloads seamlessly. It lets your organization test entirely new models as they emerge and adapt to rapid regulatory shifts, all without having to rip out expensive physical real estate or rewrite internal network topologies.
The solution to all of this is the co-location nexus. Think of it as the definitive centralized meeting point. It brings dense enterprise data into the exact same physical environment as specialized AI compute hardware, all bound together tightly by high-speed connectivity. For most major organizations today, this shared, high-density ecosystem is inarguably where their AI architecture belongs moving forward.
Section 4. The 2026 Edge Frontier.
Looking just ahead, the absolute requirement for 2026 is the edge. Intelligence is forcefully moving out of centralized regions and pushing to the extreme perimeter, exactly where the data is actually being created and consumed. For enterprise architects, this means you have to prepare for edge-native applications that process telemetry at the precise point of origin. This shift will entirely eliminate that agonizing logistical round trip back to a central cloud, preserving both your bandwidth and those critical milliseconds.
You know, currently it feels like we're living in the dial-up era of AI. It literally feels like waiting an hour to download a single picture in the 1990s. That's the harsh reality of current edge application speeds right now. It's in a completely embryonic state. The delays we experience today are entirely grounded in the physical immaturity of our connectivity fabric. But as this localized infrastructure scales out over the next year or two, those delays are going to shrink rapidly, enabling a massive wave of real-time edge applications we haven't even conceptualized yet.
Look, we are only in the very first stretch of this race. The heavy lifting being done right now, navigating power queues, scaling interconnection, building self-generation ecosystems, it's mostly invisible to the end user, but it is the mandatory foundation required for our immediate future. So, as we wrap up this explainer, I want to leave you with this final, high-stakes question. Is your enterprise infrastructure ready to survive the AI power squeeze?